Hi and welcome to another tutorial video by Int Web Design Studio, your choice for affordable web design and Microsoft Access database development. Now in this video we're going to take a look at recursive functions. Now if you don't have a clue what that means, don't worry. I'm going to cover it in some degree of detail. Now I may go fairly quickly, but that's not a problem either, since you'll be able to watch this video over and over again to catch any details that you may have missed. So let's get started. Now first let's lay some groundwork. What is recursion? It derives from the root word recurs, or happens again. In a programming context, it refers to a function that calls itself repeatedly to arrive at a solution. And we'll come back to that concept in just a few minutes. I'm going to be using a Microsoft Access VBA module to demonstrate the code and how it works. But the concept applies to almost any modern programming language. I'll be describing how to create a function that returns the result of a factorial. A factorial is defined as the product of a given positive integer, in this case we're going to use the number 5, multiplied by all lesser positive integers. Now remember that an integer is a whole number, no decimals or fractions. All the positive integers or whole numbers less than 5 are 4, 3, 2, and 1. If we multiply them together, we'll get our result. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. So 5 factorial equals 120. Now it's a fairly simple concept, but the multiplication gets kind of scary when you're trying to get the value of 400 factorial or something insane like that. That's 400 times 399 times 398 times 397. We're not going to go there today. My mind has trouble with those numbers too, so we're just going to use a simple factorial of 5. So here we are in a simplified view of Microsoft Access's VBA editor. Since we want to know the value of the factorial of 5, we're going to create a function that will tell us that. So we're going to start with a declaration. We're going to say function fact in as an integer, and we're going to return the value of that also as an integer. Now this is going to return the factorial of a given integer in. Now we're going to use 5 for simplicity's sake, but we want our function to work for any number. So we're going to pass the variable in to our function, and remember that the definition says a given positive integer. A negative number could be passed to our function though, so we're going to need to handle that. But before we do that, I want to point out that there's another quirk in the works with the number 1 as well. Now there are no positive integers less than 1. So what do we multiply it by? It can't be 0 because it's not a positive integer. So let's just say, for the sake of making it simple, the factorial of 1 is 1. Now strangely enough, the math also allows for the factorial of 0 to be equal to 1. Don't ask me to explain all of that. Honestly, I don't understand it. But let's just handle it in our function. So first what we're going to do is we're going to say that if the number we pass is less than or equal to 1, then what we're going to do is make our value equal 1. We're going to return 1. In other words, fact, or our function fact, is going to return the value of 1. Now we're going to get to the rest of this function here in just a second. Now since you can't get the factorial of a negative number, we should probably write some code to raise an error if n is less than 0. But for the purposes of this tutorial, we're just going to leave that alone and say that any number less than or equal to 0 that gets passed into our function, we're going to make that equal to 1. We're going to just make it return a 1. Now, here's where things start to get a little bit fun as we return to the idea of recursion. Now, our definition of the factorial implies that we're going to have to multiply our seed number in by each positive integer less than itself. Now, we can sort of simplify it by looking at it this way. If the factorial of 4 is equal to 4 times 3 times 2 times 1, and the factorial of 5 is equal to 5 times, I'm going to put this in parentheses, 4 times 3 times 2 times 1, we can sort of see a substitution capability here. The factorial of 4 is equal to 4 times 3 times 2 times 1. Well, that's what we have right here. So I can replace that with the factorial of 4. So the factorial of 5 is equal to 5 times the factorial of 4. 4 just happens to be 1 less than 5. So I can take the factorial, I can use this same function and take the factorial of 5 minus 1. Now 5 minus 1 is 4. So if I get the factorial of 5 minus 1, I'm going to end up with the correct answer, because the factorial of 5 minus 1, which is 4, is 4 times 3 times 2 times 1. So it works out. So what I'm going to do is, up here in our function, we're going to make our factorial equal to n times the factorial of n minus 1. So note that we're going to call the function, the factorial function, from within the factorial function. The function calls itself to arrive at an answer. So let's see how it works. We're going to start our function by calling the function using the number 5. And we're going to place a breakpoint on the first line so that we can step through and see how this thing works. So we're going to call the function. Now, since n is 5, 5 is definitely not equal to 1, equal or less than 1. So what we're going to do is we're going to continue on to the else part of our function. Now note that we don't have any answer yet. The answer, the result, has yet to be determined. And right now it's just defaulting to 0. So factorial right now is 0. So we're going to go on and step to the next line, which is the else. Now, we know that 5, the factorial of 5 is equal to 5 times the factorial of n minus 1, which is 4. So it's n times the factorial of 4. That's exactly what we were saying before. So, but we don't know what the factorial of 4 is yet. So we're going to call that function to find out. We're going to come up here and we're going to call that function. So we just come right up to the next line we call is the same function. And now we see that n is 4, and we still don't have an answer. So we're going to find out what the factorial of 4 is, right? Well, yes and no. I mean, we know that the factorial of 4 is equal to 4 times the factorial of 3, right? We know that it's equal to 4 times the factorial of 3, right? But we don't know what the factorial of 3 is. So we're going to call the same function to find out. So now we're finally going to find out what the factorial of 4 is, right? Well, no. Because right now we're here to find out what the factorial of 3 is. But the only way that we can get that answer is if we know what the factorial of 2 is. So we have to continue on, and we need to get the factorial of 2. Now the factorial of 2 is 2 times the factorial of 1. Now, we talked about before that the factorial of 1 equals 1. So when we get here and we go get the factorial of 1, well, now since n is equal to 1, this right here now resolves to true, and we will return a value to our function. Now, since n is equal to 1, we can return a value. This is called our base case. Without a base case, we'd end up in an infinite loop going around and around forever. Well, actually not forever, because eventually you'll run out of memory or stack space and your program will crash. So just as a matter of interest, let's take a look at that stack that's being referred to in your stack space. Now, we started here with n being equal to 5. That's our first step in the stack. And then we went and called factorial again with n being equal to 4. See, this little green line points where we entered into that area of the stack, or that function in our stack. Then we went to 3. Then we went to 2, and then we went to 1, and so on until we are where we are right now, with factorial just about being equal to 1. And we're going to go to the next line, and we see now that we finally have a value. So we know that the factorial of 5 is equal to 5 times the factorial of 4. And 4 is equal to 4 times the factorial of 3, and so forth. And we also know that the factorial of 1 is 1. Now here, we finally get to a point where we can use that. See, we know by our code that the factorial of 1 is equal to 1. So we can replace this with 1. Now, what is 2 times 1? 2 times 1 is 2. So the factorial of 2 is equal to 2. Now I have an answer for our next function in the stack. What is the factorial of 2? The factorial of 2 is 2. What is 3 times 2? 3 times 2 is 6. Now we know what the factorial of 3 is. The factorial of 3 is 6. So I can replace the 3 with 6. And what is 4 times 6? It's 24. Now I know what the factorial of 4 is. The factorial of 4 is 24. So I can replace this with 24. And 5 times 24 is equal to 120, which is, of course, our solution. So let's review one more time. We know that the factorial of 1 is 1. Let's move on to our next function. We know that the factorial of 2 is 2. And we know that the factorial of 3 is 6. And the factorial of 4 is 24. And the factorial of 5, which is what we wanted to know in the first place, is 120. Now you notice that the only one left in the stack is the function we're in right now. And that's all we need. That's all we needed to know. Now that is how recursion in a programming context works. We have gone through a loop to call, the function has called itself in order to get an answer. I hope that this tutorial has been helpful, and we'll see you in the next one.